Yes, you are. I've got you close the keys to 35 and 36, so I apologize. The replacement problems, I will do them right now. And it goes a little something like this. On 35, I think box, maybe it was 2, had some replacement issues to it, yeah? So here we go. I intended to see if you could do chain roll. Can you do chain roll? It'll be on the test. Without help from your math amigos or without help from whoever. It might help to do a rewrite. That's the whole thing to the 1/2. So what's outside, what's inside? Outside's a half and inside's sine. So when you take the derivative of the outside, it's 1/2 comes down, drop it to negative 1/2, and inside stays the same. Then you multiply by the derivative of the inside, which is cosine. Did you get something like that? Yes, you did. Okay, this guy is really more, sine is outside, the half is inside. So when I take the derivative of the outside, it's the derivative of sine, which is cosine. And then I multiply by the derivative of the inside, what's the derivative of x to the half? 1/2 x to the negative 1/2, or 1/2 root x. We've done that derivative so many times. All right. Did that go well? Good. Okay. On 11, looking at your homework, some of you are, I don't know if you are, you have 3 kids or something, or you have a third job, but you cannot seem to find the time to write a complete sentence for the first derivative test. The good news is, I have good news. It actually only takes about 4 more seconds to write a complete sentence instead of some nonsense like max y prime positive negative. That's not a complete sentence. I'm sorry. That's atrocious. First of all, it doesn't even have a subject. Okay, so you need to just take a second and do it well. Did you get that there was some confusion in the last class about what's the graph? My intention, that I forgot to mention, was that you locate the mins and maxes as well. So let's do that. The derivative of this is x cubed minus 16x. To find the critical numbers, I will take the derivative and set it equal to 0, and I get critical numbers of 0 and plus or minus 4. Yeah? All right. I could use shape knowledge. I know shape knowledge tells me it could look like this, but the fact that I have 3 horizontal tangents tells me it's probably this one. And the fact that it's an even function. Did you see that that was even? That there was no x cubed or x to the first. It was all even powers. Tells me it's symmetric about the y-axis. Yeah? All right. I could also do a sign test and see that the derivative goes negative, positive, negative, positive. So it tells me I've got this kind of situation. You with me? All right. So let's find, in order to do this well, let's find the coordinates of the extremum. Let's get the easy ones first. When x is 0, what's y? 2. Oh, and I said justify with the first derivative test. Pete's sake. Darn it. Let's come back to that. Sorry. I'll come back to the graph. I want to do the first derivative test. I'm all over the place. If the derivative goes negative to positive, what is that? A min or a max? A min. So I could say y has a min at x equals 0, 1 or 2? 2 plus n minus positive n negative 4, because y prime changes from negative to positive. There. Because it decreased, increased, decreased, increased. So what about at 0? Y has a max at x equals 0, because y prime changes from to negative. All right, I did the first derivative test, which I was kind of blowing through. Now, let's talk coordinates. I know that when x is 0, y of 0 is ... 2. When x is 4, y at 4, it's going to take some thought, but that's okay, I can think. If I put in a 4, then one of the 4's would divide away, and I'd be left with 4 cubed, which is 64. 4 squared is 16 times 8. What's 16 times 8? 10 times 8 plus 6 times 8. Are you with me? Is that how you would multiply that?
No.
That's not how you would multiply that? How would you multiply 16 times 8 mentally? Oh, 8 times 8 twice?
No.
Oh, how would you do it?
I would like.
Actually
like,
picture the...
yeah.
Oh, that's ridiculous.
I know.
Oh, that's... Oh, no. That's not how you would mentally multiply. No. 16 times 8, it's 10 times 8 plus 6 times 8. That makes sense. Or 8 times 8 twice. That makes sense. But that doesn't... That doesn't... No. Who can picture that?
Well, I wrote it down.
No, writing it down, it's mental math. You should be able to multiply a 2-digit number by a 1-digit number mentally. Any 2-digit. Yeah, that's not hard. You should be able to do that. What? What? Come on. You want to know why you haven't done that? Because the minute you have any kind of thinking, you go, oh, where's my calculator? Instead of...
No.
There. Anywho, negative 64 plus 2 is negative 62. By virtue of it being even, negative 4's result would be the same. So it's often, at least when I taught pre-calculus, I often manipulated the vertical scale because cubes and 4 to be give such huge numbers in terms of magnitude. You might change the scale. I'm going to go by 10, okay? Vertically. So I know I have a y-intercept of 2, which is just above the origin with that scale. And at 4, I'm down at negative 62. 10, 20, 30, 40, 50, 60, just below. And same at negative 4. I didn't ask for you to find the roots. Before graphing calculators, this would be a huge problem. You have this problem that takes a whole page, and you say find the roots and find the extreme and find the places where it changes concavity and all this stuff. With graphing calculators, they're kind of streamlined. All right, does that make sense? Delicious. All right. So how about x cubed plus x? This is on the back side, I believe. We'll get to the graphing in a minute. Let's first go these big ideas of calculus. G is increasing where f prime? Positive or greater than 0, however you choose to see it. Decreasing where the f prime is? Negative. F has a horizontal tangent where derivative is 0. Or undefined or strictly 0? Strictly 0. Undefined will actually be a sharp turn or something like that. Good try, though. F has a max where f prime goes from positive to negative. I'll take a little shorthand here because there's not much room. And f has a min where f prime goes negative to positive. So if I use the first derivative to find where the function is increasing, then obviously we'll need the derivative. What's the derivative? 3x squared plus 1. It makes me sad to see people fuddle around with this, okay? So the thought process I'd like to see you say is, well, I know the least a square can be is 0, and so the least 3x squared plus 1 can be is 1, right? If this is 0 and up, and this the whole thing then would be 1 and up, well, surely that indicates that the derivative is always positive. So f is, or y is, always increasing, because the derivative is always positive. That's because x cubed wants to do this, and x wants to do the same thing. Grow on the right, shrink on the left. They're working together. There's no even power making it dipsy-do kind of thing. You only get dipsy-doos on cubes because there's other terms wanting it to go their way. This is all grow, grow. And so it makes sense that this guy would be constantly growing because the first derivative is positive. Let's see, 1, that would be 2, and negative 2. It's not a function, by the way. I don't know if you saw that. So it should be steeper than that. Like that. Very cool. This goes to me trying to help you graph the sinusoid well, instead of saying, oh, here it's this. And yes, I actually see that on the paper. People say, oh, sinusoid, there you go. Boom. Yeah, no. Let's go through this well. What's the period of this bad boy? 2 pi. There is no coefficient on x stretching in horizontally. What's the quarter period then? If a wave is 2 pi, then a quarter wave is pi over 2. When I choose a scale, I consider what is a quarter wave, because I need to find those to make Mr. Rickman happy, and I need to horizontally shift it, which is pi over 3. When you choose a scale, then, you want to choose a scale that would be able to locate both of those for a common denominator between those two, which would be pi over 6. Pi over 6 is a good scale because it allows you to find everything of importance. You could go 1 box to pi over 6, but I think, or 2 boxes, but I think I'm going to just go 1 box. The vertical. The vertical most people are good at. What's the range of this sinusoid? What's the range? That should be -5 to -1. Inclusive or not? Does it touch those? It does. So the range is -5 to -1 because the center line is -3. And it goes up 2 and down 2 from there. That's all there. Now, here we go. We said that the original point is shifted right pi over 3, right? So where sine normally crosses at the middle at the starting point, now I'm going to shift that right pi over 3. So wouldn't that be 2 boxes over? Pi over 3 would be 2 pi over 6s. To my next point. My next point, each quarter wave is pi over 2. How many pi over 6s is that? Pi over 2 is how many pi over 6s? 3. So to get to the next point, I need to go 1, 2, 3. And that would be a max. Then 1, 2, 3, middle. 1, 2, 3, mid. And I could go back because I need to graph over the whole space. 1, 2, 3, mid. 1, 2, 3, a middle. 1, 2, 3, max. 1, 2, 3, middle. And that is accurate at all, at least at all quarter waves, and probably pretty doggone close everywhere else. All right, cool. Find the coordinates where this has vertical tangents. Confirm with sketch. Vertical tangent. It is crucial for the test that you make a connection. What does it mean? Vertical tangent means tangent slope is the derivative, and if it's vertical, draw yourself a vertical line and think rise over run. If it's vertical, what's the rise? What's the run? Is there rise? Yes. Is there run? No. Okay? So when you are looking for a vertical tangent, you are looking for where the denominator, where this derivative is undefined, or where the denominator of the derivative is 0. Where the denominator is zeros, right? Well, we can't do that until we have the derivative. So this implies then implicit differentiation. X's and Y's are mixed up. So I need to take the derivative with respect to x. What's the derivative of x squared over 4? What's the derivative of x squared?
2x.
and 1/4 just kind of comes on to the right. Now I could say chain rule and I take the derivative of x with respect to x, but dx is just 1. What about the derivative of y squared? Now this is chain rule. It's a function y within a function blank squared over 9. So what's the derivative of blank squared over 9? 2/9 blank to the first, and y stays the same. But yeah, then times the derivative of the inside. I know it doesn't feel like chain rule, but it is chain rule. Derivative of y with respect to x is dy dx. And the derivative of 1 is 0. It would be a shame to do all that calculus work on the left correctly, but then mess up the derivative of 1. Yeah? I want dy dx, so let's isolate. If I isolate dy dx, I could move over, subtract over x over 2, and divide over 2y over 9. And I could probably dump a 2, but I don't need to. Now I need to know where this is vertical, which means a 0 in the denominator. What does that imply? I need to have x or y equal what? This is vertical, then 0 in the denominator implies that y must be 0. If y equals 0, then what's x? It does say coordinates. So I don't need just the y, I need the x too. When y is 0, what's x? Plus or minus what? Plus or minus 2. That comes from the original equation. All right. So I get vertical tangents at 2, 0 and negative 2, 0. I asked them that you confirm with the sketch. What does the graph of that look like? What? A long circle. That's true. It is a circle stretched differently in x than it is in y. True. X is stretched 2 to negative 2, and y is stretched 3 to negative 3. You can definitely say an ellipse is in the circle family. All right. Vertical tangents. This would be vertical here and here, which is exactly where we say that. 2, 0, and here, 2, 0. Wait. How do you find where a derivative has horizontal tangents? Or sorry, where a function has horizontal tangents? Sorry, not a function. Where something has horizontal tangents. The numerator is right. Exactly. In that case, that would be 3, 0, 3, and 0, negative 3. All right. And then calculator skills here. So this curve is meant to be something you can't take the derivative of by hand. I want to get that you can use your calculator. Not that you would ever be tempted to do something by hand when you're allowed to use your calculator, but did you know the two things you needed to do? What's the first thing you would have to do? Plug in. Okay, so actually, let's make it the three things you would have to do. Graph that, then what? Find the zeros and store. I think there's only 1 0. And then it says find the slope of the curve at that point, so you then have to do the derivative at that point, yeah? I had 6.226 for the 0. That's the x. And the slope is negative 0.7419. Are you good with that, or do you want to walk through how to do that? Okay. I'll assume that you are good. I'll put that up here. Y equals 0 at x equals 7. Where am I at here? 6.226. And y prime at 6.226, what's the slope of the curve at that point, is negative 0.7419. All right, I think that was the last replacement problem there. Other questions on 35? Let's limit it to 3 or 4 at the most. 1, 9, 8. All right, let's go 3. That's perfect. All right, 35, number 1. Said 35, number 1. Yeah, number 1's a bit of a humdinger here. They give you this, it says rectangular prism, and which I would normally say length, width, and height. They give you a couple facts. I write them down. If I start with the givens. Surface area is 100 square centimeters, and the length equals the width. So right away, I'm going to change my picture to length zone. All right? It's a square base. They want the volume of the solid as a function of L only, which is really just laying the foundation for a calculus problem called optimization. Volume is normally length times width times height. Because width and length are the same, that means I could change it to length squared times height. Then we get to the hard part. What can I put in for h? It says write v as a function of L only. It doesn't have L only, it has h. So I need to sub in for h. When they ask you that, they'll have to give you some other relationship between the variables. What other relationship besides the volume do they give you? Surface area. I know that surface area is 2 area of the base plus perimeter of the base times the height. And so plugging in what I know, the surface area in this case is 100. The area of the base is L squared. The perimeter of the base is 4L, and the height is the height. What do I do? I want to sub in for h, so separate h out. So I think I could take out 100. Actually, I could divide out of 2 first and foremost. So I get 50 equals L squared plus 2LH. So I see that H is 50 minus L squared over 2L. Oui. So if I plug that in for H, then V is L squared times 50 minus L squared over 2L. And I suppose you could drop an L out. Although it's not really crucial that you do so because we're not going on with it. Doesn't have to be clean. All right, does that make sense? All right. How about 9? 9 is definitely one where you could do visually, graphically, but I guess the calculus practice would be pretty handy. Let's just get an expectation of an answer. What does that graph look like? Hyperbola? Hyperbola opening up and down or side to side? Up and down with a vertex at 0, 1 and 0, negative 1, yeah? So if I said, hey, what's the tangent line at 0, 1? That's here. What's the equation of the tangent line then? Well, I think it'll be y equal 1. Now, that's all right, because I'm going to practice using my derivative implicit differentiation skills and verify that that's true. So if I have a tangent line, I need a point, which is 0, 1, and a slope, which is the derivative at 0, 1. So let's find the derivative. If I implicitly differentiate, the derivative of y squared is 2y dy dx. Minus the derivative of x squared is 2x equals 0. So dy dx is 2x over 2y, or x over y. when you go to evaluate it to 0, 1, I'm going to say, hey, I'm going to evaluate that at 0, 1. Meant to the whole time. That is 0. 0 slope means horizontal tangent. Horizontal tangent is y equals some constant. If it's horizontal and it's got to go through 0, 1, then it's got to be y equal 1. You follow? Okay, last but not least, number 9. Number 8. Number 8, that's what I thought. That's where to pay attention, Ellie. You're on your game. So, first of all, let me advise you of a common mistake. And that is, you're going to see these U's and V's throughout calculus. It's a big deal of calculus. They use them all the time in lots of ways. And if you make your U's and V's look the same, then you're going to have errors aplenty. So make sure your U's and V's look very different, right? In this question, they say find du dt. That implies they want you to differentiate with respect to, bless you, with respect to with respect to time, yeah? So if I take the derivative with respect to time, then it's chain rule, chain rule, chain rule, with a little product rule thrown in for flavor. So what about the derivative of u squared with respect to time? Derivative of the outside is 2u times the derivative of the inside, du dt. Same goes on v squared. The derivative of the outside is 2v times the derivative of the inside is dv dt with. And the derivative on the right side. Now here's where things get sloppy. It's a product rule with implicit. I can see why this would mess you up because this is hard. Let's first say that 2. I'm going to decide, I'm going to lump that in with the u and call v the second term. So the product rule says take the derivative of the, or sorry, leave the first the same, derivative of the second. What's the derivative of the second? It's just dv dt plus second stays the same v times the derivative of the first. What's the derivative of 2u? Derivative of 2u, the outside is just 2, but then times the derivative of the inside u is du dt. All right, I want du dt. Do I have du dt is this yet? No? So, whose question is it? Are you on your way or shall I keep going? What? I feel like I'm just doing this for you. You're good?
I think I'm on.
Okay, cool. I don't want to do too much for you. I apologize. Sometimes I do that. All right. Let's move on to 36. 36 is next up, and it has a few slight changes. 2 or 3 aren't super changed. Do you want to do one of those to be clear what I want to see, or did that go okay? No big deal. Probably the same as the book in terms of mins and maxes and stuff. The only thing I really added is I just wanted you to justify with the first term. So the extrema should be the same. Is that clear? Are you good on the conclusions to those, or should we move on? I'll tell you what, if you have questions on those, ask them later. I'll be happy to go back, but let's go into the replacements, the actual different problems. Number 11 was chain rule. If you do a rewrite step, then it's probably wise, but I wouldn't grade for it nor require it. It does help, though, run your derivative. On the outside, then, is the 1/2. So it's the derivative of blah to the 1/2. By power rule, power comes down, reduce it by 1, yeah? Inside stays the same. What's the derivative then, on the chain rule, then you do the derivative of the inside. And what's the derivative of the inside? How you doing with the chain rule? These going to be questions you'll get right on the test. Yay, so we're on your way to 100. All right, how about this, g of x? What's the outside? Cosine. The inside is 3x squared plus 1. So when I do the derivative of the outside, what's the derivative of cosine? Negative sign. And what happens to the inside? Stays the same. But then I multiply by the derivative of the inside. What's the derivative of the inside? 6x. And that is that. Okay. College visit. All right, and s prime of t, the outside is to the fourth, so when I take the derivative of the outside, as 4 comes down, drop it to 3. Inside stays the same. And then times the derivative of the inside. What's the derivative of 3 root t? 3 over 2t, root t, sorry. Plus, what's the derivative of t? Sounds like those went pretty well. Good job on the chain rule. That's a good skill there. And then the back. The back was a little bit of a more here. It was meant to be use your notes to help you remind or review that. What are the 3 reasons the derivative doesn't exist we talked about? Sharp turn. That could be a corner or a cusp, depending on if you're dealing with curves or linear. What else? Vertical tangent. That's undefined slope. Undefined don't exist. And one more. Discontinuity. You can't have a derivative at a point that doesn't exist, or a vertical asymptote, so discontinuity. For a function to be differentiable at a point C, if you zoom in enough around the point, the curve must look locally linear. It must look linear. All right. Well then, surely on number 22, if you zoomed in around 1, it would never look locally linear, so that means the function's not differentiable at 1. What about the second one? Where is it not differentiable? Plus or minus 2. What about the third one? Where is it not differentiable? Negative 3 and 1, discontinuity. And what about the last one? Negative 2 because there's a vertical tangent there. The slope is rise but no run. That's a 0 in the denominator, undefined. All right, cool. You might have been unsure on the last about how was it show a lot of derivative, definition of the derivative work or not. I told you if it says prove or show in it, then you have to use the definition of the derivative to do so. It didn't say prove or show, so you could go at the derivative part in a little shorthand way. Let me then communicate what I would like to see. Number 1, it first says continuity, so the limit as x goes to 3 from below would use this function, x plus 2. Does that equal the limit as x approaches 3 from above, which is 5? And does that equal f at the point itself, f at 3? What is the limit as x goes to 3? From the left. 5. What's the limit as x goes to 3 from the right? They denied you? They said no college for you? Oh, well, it's nice to see you. At least you got to stretch the old legs, right?
Yep.
All right. The limit as x goes to 3 from the right is 5, and f at 3. Is it defined at any place? And that is a big yes. 5. So I would conclude then that f is continuous at x equal 3. That's part A. Any questions on part A? Did you get that part answered? B, differentiable. Because, like I said, because I didn't say prove or show, if you did something like this, does the derivative from the left of 3 equal the derivative from the right of 3? I'll take that. I didn't need to see the difference quotient of the slope quotient and the limit of the slope quotient, the definition of the derivative. Although if you did that, then I am grateful, and I would love to see it. What is the derivative of the left-hand side of the function? 1. What's the derivative of the right-hand side of the function? 0. Now, what we just then found in these two pieces was that at 3, they meet, but the slopes go straight from 1 to 0, making a sharp curve. So because of that, we conclude that f is not differentiable at x equals 3. It is differentiable everywhere else, so don't say it's not differentiable, period. It's just not differentiable at x equals 3. Cool? How about this guy? The limit as x approaches 2 from the left of x squared minus 3 would be the left-hand branch. Does that equal the limit as x approaches 2 from the right of g, which is the linear function? And does that equal the point g at 2 itself? What's the limit from the left? 2 squared minus 3 is 1, as far as I can tell. What's the limit from the right? 8. And I believe that is not equal. So we're already done. We don't need to do any more. We can say f is not continuous at x equal to the branches don't meet. And so the derivative part B is a non-issue. It said if the derivative, if it's not continuous, then don't even waste your time with differentiability. You can't have a derivative at a discontinuity. Part 3 then, or question 3. The limit as x goes to 2 from the left would be x squared minus 3. Does that equal the limit as x goes to 2 from the right, which is 4x minus 7's branch? And does that equal the point itself at h at 2? What's the limit from the left? 1. What's the limit from the right? 1. And what is h at 2? 1. It does exist, and it's 1. So we conclude, part A, that h is continuous at x equal 2. How about part B then? Is it differentiable there? Do the slopes of the parabola, which are constantly changing, smoothly transition to the handoff to a linear function? It would have to be pretty special. Let's see. H prime at 2 from below, does it equal H prime at 2 from above? Does the derivative, as you get closer and closer to 2 from the left, do the slopes approach the slopes from the right? What is H prime for numbers below 2? 2x, and that would start to approach at x equal 2. And what about the derivative of any branch above 2? 4, and I don't really need to say at x equals 2, but I think you'll agree that the slopes of the parabola do hand off to the slopes of the line. And so we conclude that h is continuous at x equal 2. Or not continuous, sorry. What did I mean to say? Differentiable. Okay, cool. All right, what other question comments? 36 do you have? 1. Ooh, scary picture. I quit or gave it some thought, just didn't get it. Scares me, yes. Ooh, scary phone problem. That's it, number 1, that's it. All right, good. Here we go. So this is where a cone comes from, is if you take a circle and cut out a sector, then you get a cone and pop up the top, get a cone. So, got this circle. Just gotta use my tools. You cut out a cone, and if you try and pinch these two edges together, to close the Pac-Man mouth, then this point pops up in the third dimension. So it goes right out here, making a cone. Where this edge here becomes this edge here where they're going to meet. Joined together. Okay. So let's talk the problem there. I understand the idea. The cone had a radius of 10. Don't know what the angle was they cut out. But it's in radians. Cha-cha-cha. Find the radius and circumference of the cone in terms of x. Let's go with the circumference first. The circumference here would correspond to what there?
Oh. It's the part that's not.
Yeah, the major arc that's not removed, yeah. So this part in black, once these are close together, it closes the circle and becomes that base. So the circumference of the cone is equal to the arc length of the circle. Are you with me? So the arc length of a circle, I don't remember how you were taught this, but I thought there's a formula. I don't remember formulas, but I do remember it's a fraction of the circumference of the circle. Yeah. What fraction is it? This isn't the whole circle's circumference. It's only a part. What part is it? That's really the hard part. The total circle is 2 pi. Awesome. What's the fraction that we kept, or the part that we kept? 2 pi minus x. Yeah? Love it. What's the circumference of the circle? 2 pi r. And that's a reference to not the radius. Part of the problem is confusing the radius of the cone versus the circle. That's the radius of the circle. And the radius of the circle is given, and it's 10. You follow? So the circumference of the cone is 2 pi minus x over 2 pi times 20. Actually, the 2 pi's go away, don't they? Times 10. All right, I think I have that part done. I think I also asked about what else? The radius. The radius of the circle here. The radius. I suppose if I have circumference, then I can get the radius, yeah? Are you with me? If the circumference of the cone is 2 pi minus x times 10, and that equals 2 pi times the radius of the circle of the cone, then the radius of the cone is 2 pi minus x over 2 pi times 10. Wait. That was a fun little bit of thinking. Don't you think? Other questions on 36? Cool. 35 and 36 are me. Make sure I get things together. Did I hear that correctly? Yes. Hey, it's so nice to be taught. Yes, sir. Yes. So, if you can't direct substitute and you can't do any algebra for cleanup, then you really get at the limit. I think the limit for the calculator is saying just doing this is really essential. As I get closer to an x zero from both sides, what does this thing approach? So you put this in your calculator and put in maybe, if you go from below, maybe -0.1. I can see where's the likewise from above, maybe plane one. When they should hope you see I need to stop this.